So, in the last session, we talked about distance and displacement, and this was a summary of the two quantities. To summarize, distance is the length of the path, which is a scalar quantity, and displacement is a vector quantity, which is a line joining the initial point to the final point, and therefore it doesn't depend on the path. Now, let's talk about speed and velocity. What is speed? Well, as long as there's a motion, there is some speed, right? Suppose I start from Bangalore at 8 a.m. in my car and go to Mysore and I reach Mysore at 10 a.m. I took 2 hours. Mysore is 130 kilometers away, but not as the crow flies. I went along the road. So the length of the path was 130 kilometers. What was my speed? What was my average speed rather? Did my speed stay the same throughout? Well, the average speed is I covered 130 kilometers in 2 hours. So the total distance covered divided by the total time taken to do so is the average speed, 65 kilometers per hour. But the question that we're asking is, did my speed stay the same throughout? Obviously not. When there was no traffic, then I actually speeded to 100 kilometers per hour. When there was traffic, I had to slow down. In fact, I completely stopped to have some coffee and the time was ticking away. Right? I'm only measuring the total distance covered, 130 kilometers, and I'm only measuring the total time taken, 2 hours. Then the division of the two gives me the average speed. Question is, how do I measure my speed at one particular instant? For that, I look at the speedometer. The speedometer of the car tells me right now it is telling me 82, right? The needle is showing 82. It means that my speed right now is 82 kilometers per hour. Right now, I may increase or decrease it depending on the traffic conditions. But right now, my speed is 82 kilometers per hour. It means if I go at this same speed for 1 hour, then I will cover 82 kilometers. But he's not waiting for 1 hour to tell me the speed, right? He's telling me the speed from instant to instant. So, how do we measure this instantaneous speed? Well, let's first define what is average speed. Total distance by total time taken. So S2 minus S1 divided by T2 minus T1, which is delta S, which is the distance covered, and delta T is the time interval. Average speed is over a time interval. In the time interval 8 a.m. to 10 a.m., my average speed was 65 kilometers per hour. And instantaneous speed means I talk of one particular instant. That means the time interval is shrinking and I make it very, very, very small. So when this delta t tends to zero, I'm taking a very small time interval. In that very small time interval, the distance that I covered, I divide the two, then I get my instantaneous speed. So in calculus, when this delta t tends to zero, then this delta s by delta t is written as ds by dt. That is a rate of change of position or the distance. Rate of change per second. So it becomes meter per second, right? So how does it measure the instantaneous speed? This is a very interesting question. Let's talk about it. First of all, speed is the rate of change of distance covered with time. It is a scalar quantity and its unit is meters per second. Meters is distance and second is time in the SI unit. And the dimensions are length upon time. There is no mass. So m to the power 0, L to the power 1, and t to the power minus 1. Now, we had seen this kind of a picture earlier in the last session. This was uniform motion. It was covering equal distances in equal times. Now, the question that we are asking is, can we measure the speed at one instant by taking a picture of the body at that instant? Meaning, if some body is moving and I take just one picture, from that one picture alone, can I tell the speed? No. That one picture only tells me the position at that instant, but I need to know the speed at that instant. So one photo will not give me. I need to take at least two photos. So suppose I take a photo at 10 a.m., the body is here. Then I take a photo at 1 minute past 10 a.m., the body has moved here, right? So I know the distance covered in that 1 minute. Then I divide that by 1 minute, I get a speed. But what is the speed? That is not speed at that instant. One was 10 a.m. and the other is 10 a.m. plus 1 minute. The two instants are not the same. So this speed that I'm now calculating is the average speed in that 1 minute time interval. So I need to take two pictures, that is very clear. But the two pictures should be taken at very short time intervals. Such a short time interval that we can ignore any variation in the speed. And in calculus, it is a very important concept that very small time interval is called infinitesimally small time interval. When I make that time interval very small, then I'm allowing the body to move and I see how far it has moved. Divide that by the time, that gives me the speed at that instant. I have to take two pictures. Otherwise, I can't tell the speed. But the two pictures are taken in a very small time interval, so small that any variation in the speed is negligible, right? That gives me the instantaneous speed. So, graphing is a very important way of depicting the motion. If I plot the distance covered with time, then it tells me a story. Let us see some stories. So, here is on the y axis the position, the distance covered, and on the x axis it is time. Suppose a body is at rest. And remember, every motion is with respect to some reference point, with reference to some origin. So if it is at rest, then the distance from that origin never changes. It will be a straight line like this. Whatever is that position, this is the origin. Whatever is the position, say it was 10 meters away from the origin when the time was zero. But as time progresses, as time increases, the position does not change. This is at rest, right? Suppose it is moving with a constant speed. The initial distance from the origin was 10 meters, but as time increased, the position is increasing like this. Say, for example, at time t is equal to 2 seconds, the position was 12 meters. In 2 seconds, it has covered 2 meters. And suppose I take 4 seconds, then at 4 seconds, it has come to a position which is 14 meters, right? If I take the first 2 seconds, it covered a distance from 10 to 12, which is this one. This is 2 meters, correct? And the time taken for was from 0 to 2, that is 2 seconds. And therefore, the speed in that 2 seconds was 2 meter in 2 seconds, that is 1 meter per second was the speed, average speed in the first 2 seconds. In the next 2 seconds, from 2 second to 4 second, how much distance does it cover? From 12 to 14, 2 meters. And the time is again 2 seconds. And again, the average speed in this time interval from 2 to 4 second is again 1 meter per second. Like that, if you take any time interval, even if it is 1 second or 3 second or 10 seconds, the average speed in that time interval will turn out to be 1 meter per second. And that is constant speed. When it is a constant speed, then it will be a straight line. And remember, we discussed the concept of slope, and the speed is the slope of the distance time graph. For a straight line, the slope is constant, meaning the slope at any point or the slope between any 2 points remains the same for a straight line, and the slope of the distance time graph is the speed, and the speed is constant. Suppose the speed is varying, it may look like this. It started, let us say, from 2 meter position, and at successive time instants, I'm plotting its distance from the origin. It is not going along a straight line, it is going along a curve. And as we know, the slope for a curve varies from point to point. The slope initially is small because the inclination is small, and at some other point the slope is larger, and that means the speed is increasing. This is varying speed example. So a graph tells you a lot of stories. Now let us talk about, from a graph of distance with speed, let us talk about average versus instantaneous. Suppose I talk of average speed, it is always in some time interval. Suppose I talk of the time interval 2 to 5 seconds. What is average speed? Let us mark those points, right? At 2 seconds, it was at a position 5 meters, and at 5 seconds, it is at a position of 26 meters. This is 5 meters, this is 26 meters. So it went from 5 to 26. In how much time? 3 seconds. So what is the distance covered? 26 minus 5. And what is the time taken? 3 seconds. The division is 7 meters per second. Average speed in 2 to 5 second interval was 7 meters per second, which is nothing but the slope of this chord. See the slope of this chord. If I draw a line joining the 2 points, that is a chord. The slope of that chord is the tan of this angle, and the tan of this angle is the perpendicular, which is 26 minus 5, that is 21, and the base is 5 minus 2, that is 3. 21 by 3 gave me 7. Suppose I reduce the time interval and I talk of 2 to 4 seconds, then at 4 seconds it is at a position of 15 meters, right? What is the average speed in the time interval 2 to 4 seconds? Well, it covered a distance 15 minus 5, and the time taken was 2. So 10 by 2 is 5 meter per second. And that average speed is the slope of this chord now. Slope of this chord. Slope of that chord is tan of this angle, which is perpendicular 15 minus 5 divided by the base, that is 2. I reduce the time interval again from 2 to 3. Then at 3 seconds, it is at this position, which is 8.5. Then the average speed in that in time interval of 2 to 3 seconds is the distance, that is 8.5 minus 5, divided by the time taken, that is only 1 second now, it is 3.5. Again, I compress the time interval, I make it 2.5 here, and at 2.5, the position is 6.5. No, it is, I think, 6, not 6.5. Then in that time interval, the distance covered is 6 minus 5, 1 meter, and the time taken was zero point 0.5, so 2 meter per second. Look at these numbers. The average speed in different time intervals is different. That means the speed is not constant. If the speed were constant, then the average speed between any two time intervals would have been the same. If you maintain your speed constant, whether you take from 10 a.m. to 10:30 or 10:30 to 11 or 11 to 12, the speed is not changing, the average speed remains the same. Just like if you get 80% marks in every subject, what is the average? 80 only. In every subject you got 80. So it doesn't matter whether I take two subjects or 10 subjects, the average that will be calculated will be the same. Likewise, if your speed is constant, then the average velocity in any time interval will be the same. Here, since the average speed is changing for different time intervals, the speed is changing. So if I talk of instantaneous speed at 2 seconds, that means I have to compress. I was compressing the time interval, right? I had compressed down till 0.5 seconds. Now let me compress the time interval, let us say from 2 to 2.1 second, right? So this is 2.1 second, and the position is just a little bit more than 5. If I draw the chord, well, that chord will be coinciding with the tangent itself, right? Correct? If I reduce the time interval, then the slope of that chord is equal to the slope of its tangent. So the instantaneous speed will be obtained by taking the slope of the curve at that instant, and the slope at that instant is the slope of the tangent drawn to the curve at that instant. So any instant you take, suppose I take 4 seconds, what is the instantaneous speed? At that instant, draw a tangent to the curve. Find the tan of this angle, which is the slope of the tangent. So the summary is average speed is slope of the chord between those 2 points, and instantaneous speed is the slope of the tangent at that point. The time interval has been compressed to a very small value. That is how we find instantaneous speed. So, simple question: under what condition would the average speed in any time interval be equal to the instantaneous speed at any instant? The answer is obviously when the speed is constant. The instantaneous speed, suppose the speed is constant 10 meters per second, suppose, constant. You take the speed at 10 a.m., 10 meters per second. You take the speed at 11 a.m., 10 meters per second. You take the speed at 3 p.m., 10 meters per second. Constant. The instantaneous speed is always 10 meters per second. If you take the average speed in any time interval, it'll again be 10. Like I said, if you get 80% in every subject, then your average is also 80, irrespective of the number of subjects that you consider. Correct? Physics is highly conceptual, right? And we must have a very strong grip on the fundamental concepts. Now, two wonderful questions that is going to teach you something. Okay, let us look at the first question. It is about average speed. A car travels in a straight line. It is 1D motion, so it will be on a straight line only. A car travels in a straight line at a speed of 40 kilometers per hour for half the distance, and the remaining half of the distance it covers at a higher speed of 60 kilometers per hour. What is the average speed of the car for the entire distance? Average speed is total distance covered divided by the total time taken to do so. But the total distance covered is not given. It doesn't matter. Let us assume some distance. And let's call this 40 kilometer V1 and 60 kilometers per hour V2. And the picture I'm drawing is it starts from A and lands up at B, and C is a midpoint. So AC is the first half, CB is the second half. In the first half, it went at a constant speed of V1. I'm calling 40 kilometers as V1. In the second half, CB, it goes at a speed of V2. The distance is the same. AC is equal to CB. C is a midpoint. But therefore, the time taken will be different. So what is the average speed? This, when I say speed, means magnitude of the velocity average. Is the total distance, but I don't know the distance. Well, let me say AC is X, so CB is also X. The total distance is 2X. All right. What is the total time? The time taken is different, T1, T2. What is T1? The T1 is the distance X divided by the speed, because speed is distance upon time, right? And speed is constant, so time will be distance upon speed. Similarly, T2 is distance X divided by the speed. X cancels throughout. We get 2V1 V2 divided by V1 plus V2. In the denominator, we'll get V1 plus V2 divided by V1 V2. So V1 V2 will go up. 2V1 V2 divided by V1 plus V2. And V1 is 40, V2 is 60, 40 plus 60, 48 kilometers per hour. And by the way, this is called harmonic mean. If you have two numbers A and B, then the harmonic mean of those two numbers is 2AB upon A plus B. Harmonic means the reciprocals of those numbers are in an arithmetic progression. You'll learn about progressions and means in higher classes. So don't worry about the harmonic mean concept and arithmetic mean and geometric mean. But right now, I think you only know one mean, which is arithmetic mean, which is the average. Average is add up all the numbers, divide by the total number of numbers. That you know. Harmonic mean is slightly different. But the point is, the average speed didn't turn out to be 50 kilometers per hour. 40 and 60, it did not turn out to be 50, the average. But in the second case, it will turn out to be 50. In the second case, same car going at 40 kilometers per hour, but not equal distances, equal times. It goes in a straight line at 40 kilometers per hour for some time and at 60 kilometers per hour for an equal time, what is the average speed over the entire time interval? So draw a picture. It starts from A and goes to B. For some time t, it goes at the speed v1, and for the same time t, it goes at a higher speed v2. Therefore, this point C is now not the midpoint of AB. If you go at a lower speed, then you're going to cover lower distance in a given time, isn't it? So AC is smaller than CB. So what is the average speed? Total distance by total time. What is the distance AC? Speed into time, v1t. Speed is distance by time. So distance is speed into time as long as the speed is constant. So v1t is the first distance and v2t is the second distance. Total distance is v1t plus v2t. And the total time is t plus t. So t cancels and it is v1 plus v2 by 2, which is basically the arithmetic mean that you know. Now the speed is 40 plus 60 upon 2, that is 50 kilometers per hour. So the learning is, if you have a body going at two different speeds for equal distances, then the average speed is the harmonic mean of the two speeds. However, if it travels for equal times, then the average speed is the arithmetic mean. Remember this. Remember this result. Okay? We are building our concepts of motion. Now, velocity. Well, simple. Velocity is a vector, which means magnitude and direction. So it is not rate of change of distance, but rate of change of displacement with time. It's a vector quantity, but the unit is still meters per second, magnitude is still meters per second, dimensions are still the same as speed. The only thing we have added is the direction concept. Average velocity will be total displacement, not total distance, divided the total time taken. So now S2 will be a vector and S1 will be a vector, and delta S is a change in displacement, is a vector, and delta t is the time. That is the average velocity in a time interval delta t. And instantaneous velocity at an instant will be obtained when you make this delta t tend to 0, then it becomes ds by dt. That's velocity. So very interesting example one can talk about: a body moving with a constant speed but with a varying velocity. Constant speed and varying velocity. Look at this body going in a circle at a constant speed v. But is the velocity constant? No. At this point, the velocity is tangential like this. At this point, the velocity is again tangential. At this point, the velocity is again tangential. I have drawn the arrows of the same length to indicate that the magnitude of the velocity doesn't change. That is, the speed doesn't change. But the arrows are clearly in different directions. Velocity is changing from time to time. And that means that there is an acceleration. We'll talk about acceleration also. So speed is constant, but the velocity is changing. Okay. Average versus instantaneous is exactly the same concept. Average velocity in a time interval is the slope of the chord between the 2 points, whereas instantaneous velocity is the slope of the tangent. So if you have a displacement, there's a displacement versus time graph, then the velocity at a particular instant will be the slope of the curve at that instant. Slope of the curve means slope of the tangent at that particular point. Whereas average velocity between any two instants is the slope of the chord. Just like we did average and instantaneous speed, same thing. The only difference is we are not talking of distance, but we are talking of displacement. Clear? Think about this question. A particle goes around a semicircle of radius r in time t. What is its average speed and what is the average velocity? Think about this. I'm drawing a diagram to help you. So it starts from the point A and goes around in a circle of, this is the center of the circle, and the radius of that circle is R, and it goes to the point B. And the total time taken is T, right? That is a picture of the motion. What is the average speed when it goes from A to B? And what is the average velocity? Pause the video, work it out, and then restart the video. Pause it. Okay. So I hope you paused it and you worked it out. What is the answer? If I talk of average speed, that means I'm talking of V average, I'm not drawing an arrow, then that is the total distance covered, that is the length of the path divided by the total time taken to do so. The distance is the path length, and that is a semicircle, that is pi r. 2 pi r is the circumference, pi r is half the circumference, and the time is t. So that is the average meters per second, whatever it is. That is the average speed. What is the magnitude of the average velocity? That is the total displacement, not distance, divided by the time taken to do so. And the displacement is initial point joined to the final point, and this magnitude of this displacement vector is the diameter. So it is 2r by t. Right? That is the average velocity magnitude, and this is the average speed magnitude. Clearly, the average speed, this is pi, which is more than 2. The average speed is more than the average velocity. In all cases, because distance is always greater than or equal to the magnitude of the displacement, therefore, in any time interval, the average speed is always going to be greater than or equal to the magnitude of the average velocity. Suppose I said that it went in a circle and came back. Suppose I said this B case, then what is average velocity? In the B case, the average speed, let us talk of first. The distance is 2 pi r now, right? And let us say the time taken was t dashed, then the total time taken is t dashed. That is the average speed. But what is the magnitude of the average velocity? That is zero, sir, because you came back to the same point. You came back to the same point. Your displacement is zero. And average velocity is total displacement upon total time. Your average velocity is zero. So average speed is always going to be greater than or equal to the average velocity in a particular time interval. This is about averages. But if I talk of instantaneous speed and instantaneous velocity, then instantaneous velocity magnitude at that instant will be equal to the instantaneous speed at that instant. That is always true. Speed versus velocity, if you look at, as we just saw, the average speed is always greater than or equal to the average velocity. But when you talk of instantaneous values, then the magnitude of the instantaneous velocity is equal to the instantaneous speed. Correct? Make sure that you have internalized this extremely important concepts. So to summarize, speed versus velocity. Speed is a distance traveled in 1 second, average speed in that 1 second. Velocity is a displacement, average velocity in 1 second. Speed is a scalar quantity, and speed doesn't tell us the direction of the motion because it doesn't have the direction. Well, velocity will tell you the direction also because it's a vector quantity. Speed is a positive number, 5 meters per second, 20 meters per second. You never say minus 20 meters per second. But velocity can be positive or negative because depending on the direction. The displacement is a vector, it will have a sign, and we'll talk of the sign convention now. In a closed loop, the average velocity is zero because the displacement is zero, but average speed in a closed loop can never be zero, as the distance moved is never zero. Like we talked in the last lecture, If a body is moving, the distance covered by it is only going to increase. It is not going to stay constant, nor is it going to decrease. It is moving, right? So it is covering some distance all the time. So it can't decrease, and also it can't remain constant, the distance covered. So that is the summary of speed versus velocity. And let us do another question on average speed. A body covers half the distance at a constant speed v naught, and for the second half of the distance, it travels at the speed v1 for half the time, not half the distance, and the speed v2 for another half time. So there are three different speeds now. What is the average speed in the whole journey? So let's draw a picture. The body starts from A and goes to B. For the first half distance, now the C is the midpoint, so that means AC is equal to CB. And AC is the first half, it goes at a constant speed of V naught. And CB is the second half, all right? In the second half, it chooses to go at a velocity at a speed V1 for half the time and V2 for another half time. Because the speeds are different and the time is the same, therefore the distances covered will be different. The point D I'm marking, CD will not be equal to DB, certainly not. D is not the midpoint of CB because V1 and V2 are different, the times are the same, the distances are different. Now, if you look at the part of the journey CB, this is an arithmetic mean. The average speed in CB is an arithmetic mean. We learned about this. If a body is going at two different speeds for the same time, then the average speed in the journey is the arithmetic mean. That is V1 plus V2 by 2. Now I can just say that it is going at V naught for half distance, right? And V1 plus V2 by 2 for the second half. Now it will be a harmonic mean between these two velocities, right? So overall average speed is the harmonic mean. Remember, harmonic mean was 2 V1 V2 by V1 plus V2, right? Now don't get confused with the nomenclature here. This V1 V2 were the two speeds in the two halves of the distance. Right now our V1 is V naught and our V2 is actually V1 plus V2 by 2. Okay. So 2 V1 V2 divided by V1 plus V2 by 2, we have this as the answer. There were three different speeds. Clear? Interesting, isn't it? So finally, let's end this session with the sign convention when you're talking of vectors. We have to indicate the direction, right? And since it is going in straight line, we can take either x-axis or y-axis. We can choose a line along which the body moves either as x-axis or y-axis. So suppose the body is having a velocity of 5 meters per second along the positive x-axis. So that means it will be a vector pointing to the right, and the magnitude of that vector is 5. It will be written vectorially as 5 meters per second or plus 5 meters per second. Plus is understood. A velocity of 2 meters per second along negative x-axis will be written as minus 2 meters per second if it is going in this direction. That is a sign convention. Similarly for y-axis. So any vector pointing to the right along the x-axis is treated positive. Any vector pointing along the negative x-axis is taken negative. Similarly, any vector pointing towards the positive y-axis is taken positive, and a vector pointing towards the negative y-axis is termed negative. And our x-y axis are like this. So velocity is a vector. We will have to say plus or minus. For speed, we don't have to say that. Speed is a scalar quantity. Velocity can be negative depending on the direction. All right. So I hope you enjoyed this one, and we will continue this topic with acceleration now.